Alright guys, today is one of those two-part lessons. So I'm going to give you the first part. You can pause the video if you want to, do the practice that goes with that, and then come back and watch the rest, or you can just continue on to the end and then do the practice set problems at the end. First of all, we're going to work with something to do with geometry that has to do with parallel lines and the transversal that crosses them. We talked about this some last year, so I think some of these terms will be familiar. We're going to find the measures of the 8 angles formed when a transversal intersects a pair of, that should be parallel lines. We're going to identify the special pairs of angles formed when a transversal intersects a pair of lines. And then we're going to switch gears and simplify an equation as the first step of a solution. So we're going to work more with those 2- and 3-step equations. Alright, this is the type of drawing that we're talking about. I've got a pair of parallel lines, and when I have a line that intersects it, that's called a transversal. And then you've got these 8 angles that have some special relationships, and we talked about some of these last year. Alright, first of all, the first thing we talked about is corresponding. And that is spelled wrong, so let me fix that real quick, or else it's going to bug me. It should be 2 R's. There we go. Corresponding. Okay? Corresponding angles are angles that are in the same position. So we basically have 2 groups of angles. We have 1 through 4 and we have 5 through 8. So if I look at number 2, it is in the upper right hand section of this group. Angle 2 would correspond to angle 6 because it's in the upper right corner of that group of angles. Alright, so I'm going to move this over to 3. What do you think would be the corresponding angle to angle 3? It would be angle 7 because it's in the bottom left position of that group of angles. Alright, now we've got alternate interior angles. Interior means that it has to be somewhere between these 2 parallel lines. So all of our interior angles are 3, 4, 5, and 6. Alternate just means that they are on the opposite side of the transversal and that they are in the other set of angles. So if I'm looking at 4, the alternate interior to 4 would be angle 5. And if I were at angle 6, the alternate interior would be crossing the transversal up to the top here, and it's angle 3. Alright, then we have alternate exterior. Exterior angles would be angles 7 and 8, and 1 and 2. So what do you think would be the alternate exterior angle to angle 2? Well, you would have to go all the way to the bottom here on the outside of the parallel lines, and it would be angle 7. If I have angle 8, the alternate exterior to angle 8 would be angle 1. And then there's a term that we talked about earlier this year called vertical angles. And vertical angles are these angles that are basically opposite each other. They're formed by the same 2 lines, and they are not adjacent. They are not side by side. They are across from each other. So angle 3, the vertical angle, its partner would be 2. If I had angle 8, the vertical angle would be angle 5. All of these pairs of angles that we listed then are congruent to each other. So if I know that 7 is a vertical angle to 6, I know that those measures would be exactly the same. And that's where we start applying this then, is when we start getting measures. Alright, so if I have a transversal line T that intersects these 2 parallel lines, and I know that the measure of A is 105 degrees, we should be able to find the measures of the other 7 angles. Alright, so let's start with an alternate exterior. Alternate exterior to A would be which angle? It would be angle H. So we know that's 105 degrees. How about the corresponding angle to A? Well, A is in the top left of this group at the top, so angle E would be corresponding, which would also be 105 degrees. If I know that E is 105 degrees, the alternate interior partner to E would be D, because it's on the inside of the parallel lines and that's on the opposite side or the alternate side of the line. Alright, now let's look back up here at A and B. We have had this pair of angles mentioned quite a bit this year, and that is that A and B are supplementary because they form this straight angle that I'm tracing right here. Well, if they're supplementary, I know that I can take 180 minus 105, and it will give me 75 degrees. So I know that B is 75 degrees. Well, corresponding to B would be F, so that's also 75 degrees. Alternate interior to F would be C, that would be 75 degrees, and corresponding to C would be G, which would also be 75 degrees. And there we have listed all 8 of our angles based on the measure of one of them. There's our vocabulary there. Again, corresponding would be in the same position. Alternate exterior would be on the outside of the parallel line, so they'd be angles up here and out there. Interior would be, whoops, let me go back here, sorry, would be angles that are inside the parallel lines. And then vertical angles, remember, are these that are opposite of each other. All right, here we're going to take a look at this transversal. You need to name 4 pairs of corresponding angles. All right, well, I know that 1 corresponds to angle 5. Okay, so I've used those. 4 corresponds to angle 8. So we've used those. 2 corresponds to angle 6. And 3 corresponds to 7. All right, those are the corresponding angles. All right. Part B says name 2 pairs of alternate exterior angles. Well, I've got angle 2 is an exterior angle, and angle 8 is its partner. So 2 and 8 would be alternate exterior. Let me switch colors here. Angle 1 is an exterior angle, and that it's alternate exterior to angle 7. So that's 2 pairs. All right, now the last set, we've got 2 pairs of alternate interior. Interior angles are between these 2 parallel lines, remember? So I've got angle 4 and angle 6. Those are a pair of alternate interior. And angle 3 and angle 5. So that's it for our corresponding alternate exterior and alternate interior. All right, before we go on then, I would like you to go in your book, and for this set we're going to do on page 713, just do letters A through D. So A through D on page 713. Then you can come back to the next topic. All right, our next topic then is just a little bit more to do with solving equations, and maybe you have to do a step or 2 before you actually begin solving. For example, it has been very rare, and I'm not even sure if we've seen it at all, where we have letters on either side, on both sides, excuse me, of the equation. Well, we can't solve one like that, so somehow we have to get the letter from this side over to the left side, okay? So let's simplify this a little bit. I'm going to add the opposite here. So this is add the opposite of x, which is negative x, and I'm going to add the opposite of x here, which is also negative x. Okay, that's a plus sign. All right. So if I have 3x and negative 1x, I end up with 2x on this side, plus 5. That takes care of the left side. And I have 17. And I've got x plus negative x, which actually cancels each other out. All right, now this now looks like something we're used to solving. Okay, so we're going to do the inverse operation. We're going to subtract 5 from each side. So I'm left over here with 2x plus 0, so the 0 just goes away. And 17 minus 5 is 12. Then I can divide each side by 2, and we have the x equals 6. All right, let's take a look at a little different scenario. I'm going to rewrite this. This will be like the copy from your book, and when you rewrite it, I would just go ahead and change it to add the opposite right away. We seem to be doing better when we do that. add the opposite of 5, which is negative 5. All right, now, this time my x's aren't going to cancel out over here on the right side. So I need to get those x's off of the right side. If I'm going to do that, I would subtract 2x from this side, which will give me 0. That means I have to subtract 2x from this side. That is 5x minus 2x, which is 3x, plus negative 17 equals, this came out to be 0, negative 5. Okay, now I've got to deal with the negative 17 and try to get that to 0. So I'm going to add 17 to this side, which means I add 17 to that side. All right, so that leaves me with 3x over here. It's 3x plus 0, which is 3x. Negative 5 plus 17 would be positive, 12. I divide each side by 3, and x equals 4. All right, we've got one more here. If you want to solve this one with me, that might help. Or you can just follow along as I do the steps. I'm going to rewrite this. And I see that I have a number times a quantity here, so I'm going to use the distributive property. So I have 2 times x is 2x minus 2 times 4, which is 8, equals to 32. And then I'm going to go ahead and change this to add the opposite. So I've got on the left side here 3x plus 2x equals 5x plus negative 8 equals 32. If I'm going to get rid of that negative 8, I need to add 8. Remember, you think of the inverse property, or the inverse operation. All right, that becomes 0, so I have 5x equals 40. If I divide both sides by 5, I come out to be x equals 8. Guys, this is the kind of work that I want to see with your equations. All I want to see is what you're doing to each side. Okay, so I need to see this step right here, the add 8, and I need to see that you divided both sides by 5 also. All right, now you can go to your practice set and do G through J. So G, H, I, and J. That would be 4 of those types of equations. And lastly, oops, let me see here if I can get to the next page. Here's the riddle for today. What would a barefoot man get if he steps on an electric wire? And we'll reveal the answer tomorrow.